Hi, this is Mathman here, and today we're going to be doing another interesting problem of parabola, which is a locus-based problem here, and the level of this problem is similar to a JEE advanced level problem. So now first read the question, pause the video and read the question, then we're going to move in. We have to prove that the locus of a circumcenter of a variable triangle having side along y-axis from a y equals 2 and this given line where the point is also given, it lies on this parabola, is also a parabola. So we have to prove that this locus is also a parabola. So we're going to plot the graph first to see what kind of triangle it's looking like. So here you can see this is the graph here. So the green line represents the y-axis, or you can say it's x equals 0, and the blue line represents y equals 2, and this red line represents the given line to us here in this question. By looking at the graph, you can say that this turns out to be the right triangle, a right angle triangle. We have to find the circumcenter of this triangle. So whenever we are finding a circumcenter, basically we are finding a point which is the intersection of all the perpendicular bisectors of all sides of a triangle. But in this case, since this is a right angle triangle, so the circumcenter will be lying on the midpoint of the hypotenuse of a triangle. This is the hypotenuse, and this is the perpendicular, and this is the base. The most important thing is this, that the circumcenter of a right angle triangle lies at the midpoint of the hypotenuse. So we have to find the locus of that midpoint of a red line. And the midpoint formula you should know before solving this is basically when 2 points are given, we have to halve the summation of the respective values of x coordinate and the y coordinate. And so here we have the points. These are the points, and we have to halve the summation of the respective values as I told you in this formula. And whenever we are finding a locus, we generally let the point let be h comma k. And so we have let this point h comma k be the midpoint of the hypotenuse, the red line we're talking about. So basically this is the point that we have to find, and we have to prove that this is a parabola at this point. So let's move in. So here we have this h equals 0 plus this point and divided by half. That's what we have done. And similarly with the point k, we have this point and this point is added and then divided by 2. We are also given that the point L, m lies on this parabola y squared equals 4x. If we look at the k, it's mostly in terms of m, and if you look at h, it's mostly like in terms of m but also L. So we're gonna make it more simple by writing this whole term in terms of m. So that's what we are doing here. So here we are writing m squared equals 4l. We have put this value in this parabola, get the value of l and in terms of m, and then we put this point back in this equation to make it mostly in terms of m, just like this point. And here we put the value, we modify that. We have 2 points now mostly in terms of m, you can see. And now we gotta do some manipulations. We put this 2 back here, it now becomes 2k. And now we have to square up this term so that we can get the value, and then we can equate to make it more simple. So here we are squaring up this equation, and it becomes something like this. We have applied the identity of a plus b over whole square, which is equals a squared plus b squared plus 2ab. And that's what we have applied here. We mark this equation 1, and now we can simply see this 1 over m squared can be cancelled out by just subtracting, and that's what we're going to do. Subtract 2 from 1, so this can be cancelled out. And now we're left with this equation, 6 over m plus 4. You can get this from here, 4 over m plus 2 over m. So this turned out to be the final equation, but it's not final. We have to get rid of this m. So we will make the use of this equation, 2k equals 1 over m because we can manipulate it. So we're going to use the equation 3 that we have marked over here. We get the value of 1 over m by simplifying it. So we put this value back in this equation. Now we get something like this. Here we have the equation. So now we simplify it more. Now we're going to add plus 9 over 4 to make a perfect square. And here it is. So this becomes a quadratic equation. We have to add 9 over 4, and then we have to subtract it because this is not in this equation. Now this becomes the quadratic equation, and we can write this. And this minus 9 over 4 goes over here, and do some calculation. This turns out to be that h over 8a plus 1 over 4. Get 8a out of this. So basically we're taking 8a common, and this turns out to be h plus 2a inside the bracket. Now we replace h by x and k by y. And this turns out to be the equation. And this is the locus that represents the parabola. So I hope you enjoyed the solution, and if it helped you, so please consider subscribing because we're going to be uploading more such videos like that.